Hi there, I'm going to talk about modular arithmetic and modulo congruence. These were concepts that I kind of lost a little bit along the way, and I really needed to go back and review and get the foundation built so that I could do more complex questions further off into the course. So modular, I'll just start with modular arithmetic. It's also known as clock arithmetic. There's things that we do all the time that come back and wrap around, like hours or days of the year, binary. There's lots of things that kind of have a cyclical way about them. So all this is, it was developed in 1801 by a mathematician by the last name of Gauss, and it's a system of arithmetic for integers, so positive, negatives, and zeros, no fractions, where numbers wrap after they reach a certain value, and that value is called the modulus. So for example, I'm just going to do up here, we're going to start our clock at 1, just like we normally do. 3, 4, 5, 6, 7, 8, 9, 10, 11, and 0. So there's no 12, but there's 12 integers. Okay, so here we have when b is divided by n, so it has a remainder of a less than n, where a is equal to all of the integers from 0, 1, 2, all the way through to n minus 1. So a equals b mod n. So it's kind of confusing a little bit there, but so the modular operation is just basically the process of finding the remainder. So here we're going to just start, and I'm just going to go through it so you can kind of see. So here in z sub 8, what is 4 plus 9? So 4 plus 9 equals 13. Well, 13 in a mod 8 world, there is no 13. So in a mod 8 world, it would be 1, 2, 3, 4, 5, 6, 7, 8 is your 0 up here. So we would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 is equal to 5. So 5 is equal to 13 mod 8. Oh, I just have to get a different pen. Okay, so and another way of doing that is to say 13 divided by 8. What is the remainder? The remainder is 5. Okay, so let's just try another one here. So in z sub 9, what is 22 minus 3? Well, 22 minus 3 is 19. So 19, so in a z sub 9, you have 0, 1, 2, 3, 4, 5, 6, 7, 8, no 9. These are all the integers. There's 9 of them, but it starts at 0. So you can just find the remainder. 9 goes into 19 twice for 18, so there's 1 remainder. So this is equal to 1 equals 19 mod 9. And that's how we would write that one. Okay, so in a z sub 5, where 3 minus 20. So right now we have a negative 17, so our integer is in the negatives. So what I could do is just show you, there's 5 integers here, 0, 1, 2, 3, 4, so our 5 is our 0, and I could go around backwards until I get to the negative 17. Or what we can do is we can realize that we can count from minus 17 until we get anywhere where 0, 1, 2, 3, 4. So we know that 17, so 17 plus 5 is negative 12, plus 5 is negative 7, plus 5 is negative 2, and then plus another 5 is 3. So we know that this answer equals is 3 equals negative 17 mod 5. So there's a couple of different ways that you could do it. If you did do 17 divided by 5, you would have to realize that that's a negative and that it's not simply 2 because there's a 0 in there. So you'd have to account for the 0. Okay, so in a Z sub 11, what is 9 times 10? So 9 times 10 is 90. So right off the bat, I know that multiples of 11, 8, 88, there's a 2 remainder. So I know for here, it's 2 equals 90 mod 11. So those are a couple of different tricks to find what your modular arithmetic is. It will be really helpful when you get to say things that are like 363 to the power of 64. Then you'll be able to use modular arithmetic to figure this out. So you start at the basics and then you work your way up. So modulo congruence. So we have A is congruent to B mod n when A and B have the same remainder n. Note that A is not necessarily the remainder when B is divided by n. Okay, so for example, here I've got my n is equal to 8. So therefore, my Z sub 8 is equal to 0, 1, 2, 3, 4, 5, 6, and 7. So that's just like saying 1, 2, 3, 4, 5, 6, 7. So there's my 8, my circle, my value. So I should have actually drawn it bigger. Let's draw it bigger down here. So 0, 1, 2, 3, 4, 5, 6, 7, because we're just going to keep wrapping it around. So this is also 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, we'll do it a couple times, 19, 20, 21, 22, 23. Okay, and then 24, 25, 26, and so on. Okay, so for example here, if we're looking at our definition, A and B have the same remainder n. Well, the same remainder here is when we're dividing by n, okay? So in this example here, we have 22 is congruent to 14 mod 8. So it's basically saying that it's the exact same number. It's congruent to. So 22 is congruent to 14 mod 8. And that just is 14 divided by 8 is equal to 6. This remainder here. And 22 divided by 8 is equal to 2 remainder 6. This is 1 remainder 6. Okay. So we have two different modulars, but they both have the remainder of 6. So 22 and 14. So I want to just write here also that if A is congruent to B mod n, if n divides A minus B, that is n minus B, also true. So also true, A minus B is a multiple of n. So what we have then is we can say that 22 is congruent to 14 mod 8, where 22 minus 14 equals 8 times 1. And then 26 is equal to, so here we have the 26 is equal to 10 mod 8. So 26 and 10, they're congruent. Sorry, 26 is congruent to 10 mod 8, not equal to, congruent to, because they're all in the same value on this. So 26 minus 14, or sorry, 26 minus 10 knew there's something wrong there, is equal to 8 times 2, because it's 16. There you go. So I'm just going to write down here for you that a minus b is equal to k times n, where k is an integer. So a minus b divided by n is equal to k. I know that this is sort of confusing, but when I write it out this way, I really got the hang of what it meant for two numbers to be the same on the same congruence. So 22 is congruent to 14 in mod 8. 21 is congruent to 13 mod 8. 21 is congruent to 5 mod 8. So I hope this helped a little bit in explaining what modular arithmetic is and what modulo congruence is. Thanks for watching.